Good day, students. We're still in lesson 12, normal models. We're doing video G. A couple of examples. Let's practice with StatCrunch. Let's relate the standard normal model to a normal model about men's heights. Okay, so a lot of different things here, but we'll need to get some practice. Men's heights are often described with a normal model. The mean is 70 inches. That's 5'10". Standard deviation of about 2.5 inches. Okay, so normal model. Mean of 70, standard deviation 2.5. What percentage of men exceed 6 feet tall? Use StatCrunch, but draw in the picture. So first thing, we do need to convert 6 feet over to inches because the normal model is given in inches. And it's early in the morning, but I do believe 6 feet is 72 inches. So we're looking for the percentage of men who are taller than 72 inches. All right, so draw in the picture. I'll put it here on the main board, and then I'll erase it when we go to StatCrunch. One skill that you need to have is to be able to draw this independently of having StatCrunch pulled up. So here's a normal model. I might even label that normal 70, 2.5. Remember those symbols. You don't need to write those in, but that's mu and sigma. I typically will draw in the mean. I'll put 70 here right in the middle. And when we're answering a specific question, okay, we're looking for the percentage of men, so we'll be shading, and the shaded part will be the answer. I don't need to label the bottom with all the tick marks, so I don't need to go up 2.5, one standard deviation, and another 2.5 and another. Okay, it's not going to hurt anything, but typically what I'll do is we're looking for 72 inches. 72 inches is not quite one standard deviation above the mean, so somewhere in here is 72. Okay, don't put it way out in the tail. Remember, this is 2 or 3 standard deviations. And all I'll do is I'll shade. I'll go straight up here. What percentage of men exceed 6 feet tall? Exceed means greater than. And so this stuff here, this is the answer to the question. Okay, because this doesn't fall exactly on one standard deviation, I have to go to StatCrunch to answer the question and to get that shaded stuff. Okay, so I think that's all the question's asking for, and it is. Make sure you can draw this without StatCrunch, but I'm going to erase it and switch over. Get the answer on the computer. All right, so here's StatCrunch. We've got a blank worksheet pulled up. And remember, I go stat, calculators, normal model. And if I pull that up, here is that normal model calculator that we use. All we need to do, students, change the mean and standard deviation to 70 inches for the mean, 2.5 inches for the standard deviation, and then we'll change this to probability x is greater than 72. Okay, so we've done this before, but always good to practice. All right, changing the mean to 72, changing the standard deviation, changing the mean to 70, changing the standard deviation 2.5. We want greater than, and greater than 6 feet is greater than 72 inches. You can see the picture looks very similar to what we drew on the board, so make sure you've got that in your notes. This answer is 0.2118. That makes sense. It's definitely less than half. It's roughly 20%, 25%, right? And that's what that corresponds to. Okay, so 0.212 if we rounded it. So to answer the question, what percentage of men, we could say 21.2%, 21.19% of all men are 6 feet tall or taller. All right, pretty easy stuff. We'll move on to B then. Let's see. If we go to the bottom of the page, it says to convert 72 inches to a z-score. Draw and shape the normal model. Okay, so Remember, our normal model for men's heights can always be converted to the standard normal model, and to do that conversion, we would need to convert to a z-score. Okay, so if I do the z-score formula up here, z equals y minus mu over sigma. I'll take 72, I'll subtract off the mean of 70, divide by sigma, and so if we put the numbers in, 72 minus 70 up top, divided by 2.5. Okay, it's a little bit less than 1, and in the notes it turns out that that's a 0.8. Always remember the interpretations of these figures. So 72 inches, if a guy was 6 feet tall, it means that he's 0.8 standard deviations above the average height. Okay, let's draw in that standard normal model. First of all, I'll put both pictures here just so I can point to one and the other. Here's that original normal model with a mean of 70 inches, standard deviation of 2.5. And what we had found was, if I shaded from 6 feet tall and above, this was about 0.212. Okay? Once I convert to z, that's 0.8 standard deviations above the mean. Here is, we would label this as a z-curve. A z-curve is a normal model centered at 0, standard deviation of 1. And if I put 0 there in the middle, I shade from 0.8. 0.8 standard deviations is exactly right here. And if I were to shade this stuff up in the upper tail, guess what? It's exactly the same answer. Okay? This arrow means convert heights over to z-scores, and we know what the answer is. To rounding, it'd be 0.212 again. Okay? Now, you don't need to do it both ways. Only one way is sufficient. And with technology, we can go to StatCrunch and get the answer. But what you need to relate in your head is that a value that's 0.8 standard deviations above the mean, how much area roughly is above that? It's about 21.2%. How much area would be below that value? It's about, what, 70.8%? Okay, so we need to have that sense of exactly what kind of z-scores correspond to roughly what kinds of areas. Okay? Now you can go on StatCrunch. I won't go back and forth every time here, but if you go to StatCrunch, pull up that normal model applet, change the mean to 0, change the standard deviation to 1, and then shade from 0.8 and up, you will see that you'll get the same answer. Okay? I know you can do it in 3 seconds at home, and it's a little bit easier than to keep turning the lights off every 5 seconds. Okay, but make that connection in your head. All right, we'll flip the page. We'll go to part C. Part C, next page. Still the same example with heights. We know this guy. He's got a z-score of negative 1.38. At what percentile is his height? What is his height? Draw normal models as needed. All right, I'll draw both pictures here, and then we'll go to StatCrunch at the end to get the answers. Okay, so we know this guy who has a z-score of negative 1.38. So maybe we'll put that one here. Here's that z-curve. That is centered at normal, 0, 1. We know his z-score is negative 1.38. If I go negative 1.38 standard deviations or go below the mean, it's roughly here somewhere. Okay, there's a z-score, negative 1.38. If I could find this shaded area, whatever that is as a decimal is going to correspond to his percentile. Okay, so I don't know what the answer is at this point, but if this was 0.10, that would correspond to the 10th percentile. Okay, whatever this area is above, we know would have to add up to 1. If we converted backwards, so we start with a z-score and we go back to y, I can go back to the normal model for height, and here's that one. This is a normal model centered at 70 with a standard deviation of 2.5 inches. Okay, so here's that one. If I were to put the same shaded area right here, make the shaded areas the same, this y value, remember that would be this guy's height. He's on the short side. He's 1.3 standard deviations shorter than the average height. This shaded area will be the same as this shaded area. Okay? And we would use the same formula to go from z back to y as we would in the previous example. We went from y over to z, right? And that formula is, that's the z equals y minus mu over sigma. Okay? That formula will take us from one to the other and back again. So in this case, we do know the z-score. We do know the mean is still 70. We do know the standard deviation is still 2.5 inches. Okay, so maybe I can get the answer here. I'll squeeze it up here. If I plug in chug, actually I'll put it right here below this. The z-score for this problem is negative 1.38. We're solving for y. The mean height is 70 inches, standard deviation is 2.5. So this equation in the box here is what we would need to solve for y. We've done a number of these. I'll just talk us through it. I multiply both sides by 2.5. I add 70 to both sides. That'll isolate y, and that'll solve for the height. That would fall right here. Okay. So if we do that, at this point in the course, you've got to be able to do that. All right. And you would convert that z back to the height. You would get about 66.55 inches. And that's the number that would go here. It makes sense, right? It's below the mean. If I got something above 70 or something obscure, then I would know it's sort of wrong. But that answer makes sense in the context of the question. Okay, so this value here is that 66.55 inches. So without StatCrunch, we've answered part of this. We've answered what's his height part. All we needed was the z-score formula. Now I'll have to use StatCrunch because I have no idea what percentage of area is below a z-score of negative 138. There's no rule for that. I have no idea what percentage of the area is below 66.55. Okay, so we'll switch to StatCrunch to get that answer and move on to the bottom of the page. All right, so I'll erase the board. You go to StatCrunch. By the time I get the lights off, you'll already have the answer. All right, we can get the answer using the z standard normal model. I can get the answer using the mean of 70, standard deviation 2.5. Okay, so I'll do both ways. Probability, I'll change x to less than, and in the notes it was a 66.55, and I'll just hit compute. Okay, so if I'm looking at the left picture that I drew, here's the normal model for heights. Probability x is less than 66.55. This shaded area is 0.084 rounded. And so that guy who is 66.55 inches tall, it's about the 8.4th percentile. 8.4th percentile. So he's taller than about 8.4% of guys, and most guys are taller than him, about 91.6%. Okay, we should get the same answer. I'll convert to a standard normal model. So to finish up part C, and getting the answer on these questions is sort of the easy part. It's understanding how everything connects together. So do make sure that you ask questions if you've got them in class. I'll change the mean to 0. I'll change the standard deviation to 1. This is now going to be a z-curve, and probability x is less than or equal to, I hope that's right, yeah, negative 1.38. If I hit compute, all right, you can see that the answer is the same. Probability that the z-score is less than that number is the same, 0.84. Okay, so either way. Okay, I guess that leaves us with D. Part D, the shortest 3% of all grown men stand how tall? Or shorter. What's the z-score that goes with this height? we'll just do this one on the board here with StatCrunch open. Make sure you can draw these pictures though. The shortest 3% of all grown men stand how tall or taller? And what's the z-score that goes with that height? Okay, so I have the z model up. We'll do z first. Z is standard normal 0, 1. Looks like we're going for the 3rd percentile, the shortest 3% of all men. The z-score will be somewhere down here. I'm trying to think exactly where this might go. Well, I don't know. I'll see if I can do as good as Kim did in the other video. Somewhere here is about 3%. This would be the top 97%. Okay. And that's the z-score. We're asking for 2 things here. That's the z-score. What I can do, I'll leave the mean at 0. I'll leave the standard deviation at 1. And we're solving. StatCrunch doesn't know we're working with z, so it still says x less than. In the box here, I put equals 0.03, and I'm looking for the value that puts 3% in the left tail. Okay, not too shabby. Missed it by, I don't know, 1/4 inch there. That number right there, and you can see in your notes, it's a negative 1.88. That's the z-score. If I go negative 1.88 standard deviations away from the mean or below the mean, then 3% of the distribution is even below that, and 97% is above it. Okay, so that's the z-score. That would do the job. All we need to do now is the same thing. I can just change over to heights. Mean of 70 inches. That's the average height of guys. Standard deviation of 2.5. And get rid of that. So if I clean up the picture, the area breakdown will be exactly the same. Mean of 70, standard deviation 2.5. Area to the left of what height is 0.03. Hit the compute button. And if you're a guy and you stand at about 65.3 inches, so that's about 5'5" and a little bit of change there. So if you're 5'5", according to this model, then you stand at the 3rd percentile. And 3% of guys are shorter than you, 97% of guys are taller than you, if that's where you stand. All right, hopefully things are making sense. Very important skill to have, being able to work with normal models, being able to work with standard normal models, get z-scores and convert back from one to the other. So, practice, 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 and thanks for watching. We will see you in class.